Generally, to understand this correlation, two types of analysis can be done, which are one, autocorrelation and cross correlation. Autocorrelation represents understanding how one variable is having interrelationship with itself. In the same way, cross correlation represents how two variables are related to one another. Similar to the figure we observed in autocorrelation of precipitation, there is a decreasing trend which is quite understood as the trend decreases as you go back, but it has some information which can be used. You see here, the zeroth lag does not have the highest correlation, as today's precipitation and today's discharge are not highly correlated. It is quite evident because it's not very common in any watershed where today's precipitation is directly influencing today's discharge, because if there is a precipitation continuously going on since few days, yesterday's discharge and yesterday's precipitation also has a very high impact on today's discharge. If you have done that, you can do by trimming out till here. You will remove the first four elements. Although the date changes, but still the concept of having a lag remains the same. So if you see here, to have the value of 5.5721, what this is the output you want, and what are the data sets you are using? You are using from 1.4, and it's before day, and it's before day, and it's before day. So this is like 1st of January, 2nd of January, 3rd of January to get 4th of January. Welcome back to the channel. In this video, we will see how we can apply the concepts of what we have learned in the previous video and see how those functions work in Matlab. So let's directly get into the concept. So let's go into Matlab and see how we can perform this autocorrelation and cross correlation. If you see here, I have already inputted the data with first column representing precipitation and second column representing the discharge of a certain location in India. So if we see, if we use the command autocorrelation of data of first column, here we need to give only one column because autocorrelation refers to one element having its interrelationship. So if we press enter, you can see that a figure pops up, and what do this figure represent? So if you say the x-axis is termed as lag and the y-axis represents the amount of correlation, the 0th lag has the highest correlation with a value of 1. So what does this represent? The 0th lag represents the correlation of this column with itself. So it is like, if you see here, this column is finding out the correlation value with itself like this. So that's why you have one correlation. But if you go to the first lag represents one variable before this element. So if this is the first element, you are saying it is having a lag of 1. This data set represents you leave the first row and then paste the whole thing, and this represents the first lag. Similarly, if you leave 2 and do this, second lag, leave 3 and do this, third lag, and so on. So that figure represents correlation of 0 lag. This represents the 0 lag. 1 and 4 represents the first lag. 1 and 5 is the second lag. 1 and 6 is the third lag, and so on. So that is what this figure represents. So how do we find out how many lags can we use for analysis? So there is a constant value which we can use, which represents anything above 0.2 correlation can be considered competent for use. So if you see here, whatever the value which you are seeing above 0.2 can be considered as competent for use. But it does not mean that you have to use only 0.2. If you want to put a limit of 0.3, you can go ahead and put a limit of 0.3 and say, let's assume if the 0.3 is here, and if we see, we might be taking only few variables into context and analyze them. So how do you know how many lags are above 0.3 and so on? So to know what each lag variable is having correlation, you just save the same function. If you remember, if you press the upper arrow key in the command window, the same commands come up. You can just put a variable a representing the values. So if you see here, and if you plot it using the plots, you can see the correlation decreases as the number of lags are increasing. This is quite evident because as you go back and back, the amount of correlation between the today's date and maybe 10 days before is quite different, but it has some amount of knowledge in itself. So if we see the values here, you can see that the values are dropped from 0.6, 0.37, 0.32, 0.32, 0.33, and so on. So you can choose, for example, you can take around 5 or 6 here. If you see, there has been a drop until here and a sudden increase and again a decrease. So you can stop until the 7 values here. So it will be 6 lags. This is the 0th lag. 1, 2, 3, 4, 5, 6, or even 5. So you take these 5 variables and say these 5 variables can be used to be able to predict the value of today, because they are having sufficient information in itself which can be used for analyzing this today's value. So combinedly using all the 6 plus today's, you can develop a model to predict tomorrow's precipitation, as you have good amount of data in itself to predict the trend. So this is how an autocorrelation function can be used. So what does cross correlation function do? So if you see cross core of data, first column comma second column. So why do we need to give two here? Cross core generally represents relationship between two variables. So we need to give it two inputs. So when we just run it, this gives you again a similar figure but with different contexts. Again, the x value represents the lags and y represents the amount of correlation. So this correlation represents how the discharge and precipitation are in relationship with one another. So if you are trying to predict tomorrow's discharge using today's precipitation and today's discharge, so how many correlation or how many lags can we use to understand it? So if you see here, the 0th lag does not have the highest correlation, as today's precipitation and today's discharge are not highly correlated. It is quite evident because it's not very common in any watershed where today's precipitation is directly influencing today's discharge, because if there is a precipitation continuously going on since few days, yesterday's discharge and yesterday's precipitation also has a very high impact on today's discharge. So in this way you can see there are both negative and positive lags, but we will generally be considering the positive lags to determine how many lags we can use for predicting. So if you see here, there are quite a number of lags shown. Again, you can take the confidence limit based upon your interests and see how many lags you can use for understanding this relationship. So to have a better understanding about how each lag is contributing, we can again save this with a value b and see what the values are. If you see the values, again we will plot it using by clicking it here and going to plot. So if you see, there is an increase in correlation with a 20-second lag and again a decrease. So if we just again observe a cross correlation plot, we can see that in the positive correlation side, uh, we can take up to 5 lags or 6 lags if we take a correlation value of zero point 0.4 as your confidence limit. So this would be the 0th lag which will be having the discharge with itself, and we can take the precipitation values of 1, 2, 3, 4 and 5. So until the 5 lags, there is a good cross correlation with one another. So here the precipitation up to 5 lags is having a very good influence on discharge. So in the context, if you remember earlier, we have done only precipitation on itself, the first one, autocorrelation. So that concept can be used when you are trying to analyze or predict precipitation only. But in a context of trying to predict discharge, we use the cross correlation value of 5. So now we know that we can use 5 values of precipitation for understanding discharge. But yesterday's discharge also will be influencing today's discharge, right? So we can use the same autocorrelation which we used earlier to understand how discharge is related to itself. So if you press autocorrelation, the values are saved, and if you want to see the plot, you'll run it again like this and see that similar to the figure we observed in autocorrelation of precipitation, there is a decreasing trend which is quite understood as the trend decreases as you go back, but it has some information which can be used. Similarly, you can use anything above 0.2 or put your own confidence limit in relation and take the values. So let's assume we are taking up to 5. So if you see a zero point 0.4 value, you can see that there are around 8 or 9 values which are above zero point 0.4 confidence limit, which can be used for predicting the discharge itself. So now, for example, let's assume you are thinking to develop a rainfall runoff model using this data. So how can we develop a very good model? So if you use only today's discharge and today's precipitation to give tomorrow's discharge, you can develop a model. But to have a better model with better understanding of the background of trend, you can use 5 precipitation lags, which represents, that is in the data set, you can write like this. If you remember, the first lag, second lag, third lag, and you leave the 4 and 4th lag, so on till 5. And similarly for the discharge also, you'll do the same things and have 5 or 10 in the previous, as I have seen, 10 sets and develop the model. But one issue with this lagging is, if you see, if you go to the lowest column, you can see as you increase the number of lags, the number of elements also increases. So initially there were only this many elements, but now we have more. So what one can do is you can trim out the data. Let's assume you don't have earlier data of this date. So you have to use zeros to do it. But what one can do is, after we have done that, you can do by trimming out till here. You will remove the first four elements. Although the date changes, but still the concept of having a lag remains the same. So if you see here, to have the value of 0 point, sorry, 5.5721, what this is the output you want, and what are the data sets you are using? You are using from 1.4, and it's before day, and it's before day, and it's before day. So this is like 1st of January, 2nd of January, 3rd of January to get 4th of January. So this is how you can work out to find out the lags and put the lags in a certain context to use for developing a model. This concept in the end is quite tricky, which I'll be again explaining it to you in the next video, where I'll be developing a model to show you how you can use this concept to develop a model. So this is the general context of what autocorrelation and cross correlation functions are, and how you can use these functions in developing a good rainfall runoff model. So I hope you have understood the concept. If something is not clear, please put your questions in the description and I'll be happy to answer them and clear them to have a better context of understanding. So I hope this concept is understood, and if you liked the video, please give a thumbs up and subscribe and share it with friends who might be interested in learning this concept to apply them. So that is it for this video. In the next video, we'll discuss how we can use this concept to develop a good rainfall runoff model. This concludes the part 2 of the video. In the next video, we will see how we can use these concepts to develop a good hydrological model. If you understood the concept, please give a like and subscribe to the video, and let me know any questions which you have in the comments so that I can answer them. See you in the next video.